Hello guys, how are you? I'm not Alex. I wish I was, but because both, like he's CEO and 2 meters tall. But it's not me. I'm Kamil. I'm from P2P. I'm 50% of the P2P's marketing team, and P2P is staking provider, which means we allow your client to stake. So we could delegate to P2P. We are one of the biggest operators in the market, pretty huge in Ethereum, and definitely top one in AVSs. Right now, let me just introduce the debate, or it's not even a debate, but it's Pavel Yasin, the researcher from P2P. He's going to interview Ellie Davidson from Espresso, so welcome on stage, guys. Come on, we need Espresso and we need Pavel Yasin. Godspeed, guys.
Hello, you can hear me, right? So hello everyone, thanks for coming. Unfortunately, AJ couldn't make it, so we're together with Ellie here to have a small discussion about some quite deep and academic topic, but we will try to keep it high level. So we'll be talking about enshrined versus external shared sequencing. Let me try to give a little background behind the topic. So right now we have dozens of rollups. All of them are quite sovereign chains with their own tech stack, with their own policies, and they're fragmented a lot, right? And shared sequencers are trying to solve this problem, enabling high-level composability between rollups and the possibility for applications to communicate with each other, like in a matter of a single block, for example. So there is some atomicity in some cases. At the same time, from the L1 perspective, there is a question of L1, L2 value redistribution. And there are questions to rollups whether they possess all the qualities that base layer has. And I was wondering whether enshrinement of shared sequencing or some of the part of shared sequencing can actually solve the problems both rollups and L1 and actually create a viable ecosystem. So Ellie, could you please introduce yourself and tell a little bit about you and project you're working on?
Hello, I'm Ellie Davidson. I am the head of R&D at Espresso. Espresso is building a confirmation layer, which is actually live on mainnet now. And the whole purpose of this confirmation layer is to allow for much faster interoperability between L2s than you can get today.
Great, thanks, Thales. So the first question is, what do you think are the parts of shared sequencing can be enshrined? What do you think is a good thing to have inside a L1 protocol to be governed? And what benefits would be for rollups and for the protocol?
Yeah, this is a good question. So I view enshrining sequencing in the L1 very similar to based sequencing. Based sequencing, if you don't know about it, is where the L1 proposer sequences for the rollup. So I think that they're very similar. I think the benefits of this are that, well, you get the decentralization of the L1 proposers, which is very good because that means you're essentially decentralizing your sequencer because each new block, someone else will be building it. And it's also good because Ethereum is the neutral layer that everybody can agree on. So if rollups all choose to use the L1 as their sequencer, then you get a really good shared sequencer just because you have a lot of rollups that are using it.
So from your perspective, base sequencing is actually a case of enshrinement, right?
Yeah.
Okay, great. So what do you think are the problems of enshrining sequencing? What are the major drawbacks and whether risk taking actually can help to solve them?
Yeah, so in my opinion, you can kind of do quasi-based sequencing, so you can get some of the benefits of base sequencing without the drawbacks, but I think the drawbacks of only doing base sequencing where the L1 proposer is building your blocks is a few things. So Currently, the L1 block time is 12 seconds, and that's kind of long. You can offer users pre-confirmations before the 12 seconds to give them a better user experience, but ultimately, it's better if you are actually putting blocks on the blockchain and finalizing them. So potentially using some other protocol that can finalize transactions faster might be very useful. And I also think the biggest thing is that the current MAV pipeline, so currently on the L1 today, the L1 proposers do not build blocks for Ethereum. They actually outsource it to these builders and searchers who build the most profitable block. And then the L1 proposer proposes it on the builder's behalf. And if you're talking about based sequencing, you're kind of naturally inheriting the same problems that this L1 MEV pipeline has, which is not ideal. So I'd say those are the two downsides.
Oh, okay. So in case of base sequencing, it means that, like, say, two biggest block producers, block builders, sorry, they will actually also build all the blocks on L2s, right? And I think, like, without additional commitments, it isn't possible for L2s to control the value of their chains if they're Go based, right? So what do you think are the best tools to communicate the preferences of L2s?
Yeah, so I think the best tools would be in what's called the derivation pipeline, which is basically where the L2 takes whatever was sequenced for it and then translates it into a valid block for them. So you can do a lot of enforcement of ordering rules in this derivation pipeline. For example, you could enforce that something is ordered by priority fee. You could enforce that the transactions are randomized, some sort of a random order, which is, and this is good because if someone does not build the block to those specifications, it will literally not be finalized on the rollup and they won't earn any money. So they're very incentivized to do it. However, it's much trickier to do something like first come, first serve, because that's a really difficult thing to prove, because how do you prove that the timestamp in first come, first serve ordering is honest? But yeah, I would say the best way to do it is through this derivation pipeline where the rollups just say, hey, if you don't sequence the block in a way that I find acceptable, I'm just going to reject it.
Okay, cool, nice. So now let's talk about external shared sequencer. As far as I understand, Espresso's, I guess, the main product is to build external shared sequencing, right?
Yeah, this is a good question. So actually, Espresso can kind of facilitate this quasi-based sequencing that I call it, where we allow the L1 proposers to sequence blocks if they want to, but then if the L1 proposer does not want to sequence blocks, then someone else can sequence them. So you basically get an L1 proposer sequencing your blocks, every few blocks or so. So it's kind of in the middle.
Yeah. So do you think that external shared sequencer worse than base sequencing because of having their own security, own economic security, and that's why they only partially inherit the security from the layer 1?
Yeah, this is a good question. Personally, no. I mean, it definitely depends on actually how much economic security you have. So, I mean, sure, if you have an external sequencer and it's only backed by $10, well, yeah, that's not good. But I think in the realistic case, they can be backed by quite a lot of stake to make them very economically secure. And then also in the case of Espresso, like, it's a distributed network. So you not only have the stake, but you also have the network of different parties, which also makes it more difficult to bribe. But this is also where something like restaking really comes in, is because you're actually reusing the Ethereum staking security. And hopefully over time that will, sorry, the security of the stake in the network will be very, very high. So I also think that there's advantages that an externalized sequencer can offer that base sequencing cannot. I think one of those is like really fast finality. which is just you're finalizing things way faster than the L1. And you can actually design it so that a rollup requires finality from this outside protocol before L1 finality. And this means that unless your decentralized sequencer completely falls apart and equivocates, that if you see something confirmed on this outside decentralized sequencer, you can guarantee that that will be confirmed on the L1 eventually, and nothing different will be confirmed. So I mean, I'm obviously kind of on the side of external sequencers, but yeah.
Well, it's no problem. It's okay to be biased in this case. But anyway, you were talking about that at some point of time, shared sequencing, some shared sequencing can get big enough economic securities so that it will be secure enough. But I'm wondering if we believe in Ethereum rollup-centric roadmap, for example, right? And we believe that most of the economic activity will move to L2s, for example, on up chains or specific rollups for DeFi, for example, right? So it will actually mean that the amount of value that is transferred on chain and locked on chain will be as high as on L1 right now, but still it will have only a fraction of its security. So the things will get worse in this case, isn't it?
I don't think so. At least in my opinion. I think that Ethereum will always have like such high economic security available to it. There's so many people who want to stake, and so I don't really think that that's an issue. And then about this value moving to L2s, I actually think this is a really good way where you actually use the L1. So with an L2, you settle to Ethereum after some time. And so you're trusting Ethereum. And I think that you can design rollups such that they settle in a way that is safe. So, they aren't going to have a double spend. They aren't going to have, mint something and not burn it or anything like that. So I think it depends. If you design your smart contract where you settle on Ethereum well, I think you can kind of get the best of both worlds.
All right. Just a quick question before we give word to AJ. This finally right. That's fine. I'll just give you to catch your breath. So a quick question to Ellie, follow-up question about base sequencing. So don't you think that pre-confirmation actually enable fast finality on base sequence rollups?
Oh, this is a good question. So pre-confirmations are backed by stake. And if you trust that stake, then I guess, yes, you can consider them final. And that's probably good enough for like low value transactions. I think that there definitely is a lot more benefit, though, to something that is more robustly final. I mean, if you just trusted a pre-confirmation, then, why would you want to settle to Ethereum at all? So yes, I think that pre-confirmations can be backed by a lot of stake, which makes them very powerful, but I don't think that they're as powerful as a distributed network of nodes, such as Ethereum, coming to consensus on a single value.
All right. Okay, I want to give a word to AJ. Yeah, let me just give you a short summary of what we're talking about today. So we are trying to compare enshrined and external shared sequencing, right? Do you think that enshrined or based, to some extent, it's a form of enshrinement, can give better guarantees for L1 and L2s versus external shared sequencing?
Yeah, of course. If we could implement this enshrined shared sequencer in practical way, I think there would be many benefits that would get from that architecture, I suppose. Like, for example, we can provide a better user experience for our layer 2s, also better the finality for them as well. And then also we can generate much more revenue as well if these searchers use this shared sequencing approach to build cross rollup MEV stuff, so that can bring more revenue for rollups as well. So I think that's the great way to implement.
All right, thanks. Do you think also that restaked sequencers, I mean, external restake sequencer are actually secure enough to be viable.
Yeah, that's why we built our own secure block building as an AVS to provide rollups, better security, and censorship resistant, and also MEV resistance by using the encrypted temple. So I think, we don't need to provide the same level of like decentralization or security for layer 2s as layer 1. Rollups. The ultimate goal of rollups is the provider scalability, not like you can just excuse this trust assumption for rollups as well. So that's why I think restake security could bring benefits for rollups as well.
All right. So Ellie, do you have anything to add, or you disagree with something?
No, I would say I generally agree. If there's only one thing I would maybe slightly push back on with enshrined sequencing is that if you are going to enshrine it in the L1, you should make sure that it's incredibly flexible so that rollups can have a lot of customization and sovereignty over what they do. And I think with the way base sequencing is going right now, I think it is very flexible, and this is a really important task in the base sequencing kind of research group. But like always, I would be careful of saying that of enshrining too much, I guess.
All right. Well, unfortunately, we're running out of time. I need to wrap up. I'd say that both types, enshrined and external shared sequencing, kind of great concepts. They all have their own benefits. And honestly, I think that, speaking about restaking, that it actually enables those fast use case testing, right? Proof of concept testing. And I guess without it, maybe external shared sequencing won't be able at all, from my perspective. Do you want to say something else, guys? Like last word?
No, I don't think so.
All right. Thank you guys for listening. I will invite Camille back on the stage.
Thank you, guys.
Thank you
for AJ for making it. And I have a great news for you guys. And it's not just the market. It's Alex Yesin made it here. Like, he made it through the Bangkok traffic. So meet the tallest and the strongest guy here in this place. Guys, Alex, the great Alex Yesin.
Hey, guys. Thank you for joining us today. That's an amazing day. To be honest, it looked like it's a stand-up comedy. And you need more shisha maybe. And I also saw, more TIE fighter behind the scene. I hope you will have a nice performance today. But maybe you will know our company is the biggest staking and restaking provider in the world. And despite of this, we couldn't pass the upcoming revolution and which new technology brings, like FHE, TE, and of course ZK. We are a strong believer in ZK technology and all of them. We are a believer that this technology will bring new, several millions customers to crypto, and also will open the new scenario in DeFi and payment system. We participate in a lot of research, and our main focus how we can optimize usage of GPU, and at the same time, how can we make proofs faster, cheaper, more affordable for mass market. And if you are building some products based on layer 2 or based on this technology, we'll be happy to discuss it. We will be happy to participate in different LGLs. Guys, let us know, and thank you for your time.
Thank you, Alex. Thank you. So right now, it's a recap, and it's a recap before the final knockout round. So probably you're going to see some blood, you're going to see some sweat, but first of all, let's introduce some AVSs to the stage. Let's see what players do we have here. Such a great names in the crowd. So first on stage is Jason Vranek, the CTO and co-founder of Puffer. Could we get Puffer on stage? Okay, it's an instant knockout because Puffer couldn't come. Okay, so we have Ali Davidson, the head and research and development from Espresso. The stage is yours.
Yes. All right, let's go. So I'm going to be talking about the Espresso confirmation network and composability. And so what is a confirmation network to begin with? Well, basically, you have two rollups, and you want to send messages across rollups. You want to bridge across rollups, but it's hard to do that because the rollups don't have any way to communicate with each other. So today, you have to go through the L1, and that's very slow. What you want is to be able to freely pass messages between the rollups without having to go through the L1 at all. So, and this gives you composability. And I'm going to define composability as one rollup state relying on the other state. So fundamentally, when the rollup does its state transition function, it's taking in the state of another rollup. And so yeah, this gives us composability, which is awesome, and this is what we want. But, well, why do we need a confirmation network? So rollup A and rollup B don't necessarily trust each other. So for example, let's say rollup A says that it burned some amount of USDC, and then rollup B mints it, but rollup A did not actually burn it. So this is a problem. And the other problem is that B doesn't trust the sequencer. You have some external sequencer, and maybe they're trying to do something bad as well. So how do you fix this? Well, this is where the confirmation layer comes in. You need something that both rollups can trust. So a really good confirmation layer is the L1. That's what people use today as the confirmation layer for rollups. This is great, but it's also slow. So what you can do is have another confirmation layer that's purposely designed to be very, very fast, but also economically secure. And this is done through restaked nodes, and these build really strong economic security. So with that, Espresso mainnet is live, and our network is...
Oh, the time is out, but Ellie, please stay with us because
Okay.
there's also like a knockout round in a moment. And right now, let me introduce D.H. Lee, the developer from Radius. Okay, so there's Q&A of 1 minute. So Ellie, your Espresso systems, let me ask you, like, what are you brewing right now as a development and research department?
Yeah, so right now we're super focused on composability. So we're building this neutral protocol that's outside of Espresso as a way to express messages between rollups and make sure that you can cryptographically enforce them at settlement time.
Perfect, thank you. So right now, let me introduce on stage, or maybe you guys have like one question for Ellie right now. So let's have D.H. Lee from Radius on stage. Come on, man. 1 minute presentation, 1 minute Q&A. The stage is yours.
Thank you. Hi, everyone. Glad to be here for the second time, explaining our block building solution. This time, it's a secure block building solution, and I'm going to be explaining why. And so basically, Radius AVS is about secure block building for censorship and MEV resistance. So here's how we achieve this. So when the user's unencrypted transaction gets sent to the secure RPC layer, it gets encrypted for a certain period of time. And within that period of time, the Radius AVS and its sequencing module is bound to give back to the user the order commitment, which is equivalent to inclusion guarantee that their transaction will be included at in the certain block number at certain index. And this is being carried out while the transaction is encrypted. And while the transaction is encrypted, it gets multicast to the rest of the cluster. And the rollup executor requests the block. And after the decryption, the encrypted block consisting of decrypted transaction gets sent to the rollup executor to be executed. So, and on top of that, the block commitment task is made by the one who proposes the block to the rollup executor, and the event is emitted, and the rest of the sequencing module in the cluster is there to validate the block. And that's it. Thank you. We had a technical difficulty with the QR provider, so we couldn't include the QR. But everything is open source right now, and you can check it on our GitHub. Thank you so much.
Okay, Lee, but it's not that easy. Like, I know your QR code is not working, but you have like still like 1 minute on stage. So
All right.
tell us like what was behind the QR code then.
Yeah. So anybody has any questions? Yeah.
So you said you are encrypting the transaction before sending it to the AVS clusters. So what kind of encryption are you using? And if you're using keyed encryption, then how are you protecting it from, if you're going to be sending it through the network, so how are you protecting the keys? Since I saw you also have decryption, that means there's a key involved in the encryption process.
This is going to take a real while to be explaining it to you right now, so I'll be waiting at the back of the stage to explain it to you in full details.
Sure. Thank you. Thank you.
Okay, thank you, Lee. So stay with us because there's going to be a knockout round in a moment. But right now, let me introduce on stage Hersh Patel from Opacity. And this is the founder. Hey, man, good luck. The stage is yours.
Testing, testing. Hey, everyone. I am not Hersh Patel, as some of you could probably see. My name's David. I run go-to-market and vibes and things like that at Opacity. Unfortunately, Hersh couldn't make it, but I will do my best impersonation today. So Opacity is building a verified data network, empowering users to take ownership over their data. The rough thesis here is that we live in a poverty of verifiability. If you own data on the internet, you can't actually do shit with it if you can't prove to someone else that it's your data, right? So any sort of incentive rewards, any sort of porting of your social graph, it's impossible today. Not me. Hersh navigated this for a while and did his best shot. He went through demo, he was working on the Farcaster identity contracts until he eventually arrived at a solution that got past this roadblock. Because ideally what you'd have is you'd have the data providers sign their data, but unfortunately that can get rugged at any time. Unfortunately, there's no incentive for anyone to share that data and make it easy for you to move it around. So what we do is we build off the existing HTTPS infrastructure. This bypasses the need for cooperation, and anything that is available in a web or mobile app is now available to be verified and brought on chain or shared in another manner. So obviously we're in EigenLayer AVS, and the developer platform is actually live. You can try here at app.opacity.network. And just a quick note on some of our partners. We're doing vampire attacks on Instagram. We're doing it on TikTok. We're doing it on a few others as well. We're working with Daylight, and I'm watching my time very closely. But this is really the crux of it. ZK-TLS is the future of how you're going to get consumers on-chain, because now that you can incentivize the correct ones by targeting them, it makes it easier for everyone to actually want to do something with all this technology we're building. That's time. Thank you, guys.
Thank you, man. So do we have questions from the crowd? Yeah, there's one question.
You would. Go ahead.
How is Uno using Opacity?
Yeah, so Uno is a really interesting partner. They are doing somewhat of an Instagram clone, but on the Farcaster network. And they'll be digesting the data from your actual feed on Instagram, on Spotify, on TikTok to curate your experience, but on a decentralized network. So it'll be entirely your feed, as you would have it informed on any of these other social networks that you're used to, but it'll be, your ownership of your own account as you would expect.
So you're using Instagram data to create like a recommendation system for serving Farcaster data?
Yeah, exactly correct. And obviously today that's mostly Warpcast, but the hypothesis here, you can bring more interesting data to the Farcaster network if you have an engine that can actually recommend it.
Amazing.
No, you, buddy.
That was pretty quick. Thank you for making it in time. And right now, let's welcome on stage Diego Kingston, the co-founder and head of research from AltLayer. Oh, we have some fans in the crowd. That's good. Cheer for you guys.
Thanks a lot. So the idea is that blockchains achieve verifiability by doing re-execution and consensus. Okay, but this is expensive. So the idea is that with succinct proofs, what we can do is basically move execution of chain. Okay, and that allows things to scale. The thing is, verification is super expensive, so we cannot run more than 10 proofs per second. In Ethereum, there is no parallelization, there are lots of problems, and so that limits the kind of applications we can build on top of Ethereum. So here are some numbers. You have to pay at least $6 to verify a simple cross-sixing proof. So the idea is we could do it by doing either recursive proof generation or something like that. But what we could also do is build our own blockchain. But here is where Eigen comes in. Okay, why not build a decentralized network secure by risk-taking to verify proofs and post them into Ethereum, okay? And by doing this, we can get many cool stuff, such as fast bridging, fast finality for rollups and app chains, CK oracles, on-chain gaming, and other cool stuff. Okay, and so the idea basically is we are going to interact with a patcher who's going to send tasks to Ethereum, and then this network will just verify the proofs, send a signature saying that everything is correct, and then we are going to aggregate, post to Ethereum, and then you can get your result for cheap. Okay, and we can verify more than 10,000 proofs per second in testnet, and looking forward to mainnet. It's coming soon. See you.
Okay, we still have some 10 seconds. Is there a question in the crowd? We have one. Can we get the mic?
So I understand that aligned is the, well, you call yourself the universal verification layer for Ethereum. So how many proof systems are you supporting right now?
Right now we have 5, but we are planning on adding more. It's really easy. It takes like maybe 1 day of work to add a new proof system. But we are starting with the main ones that are being used in production, mainly Starks, but also GNARC and other cool stuff.
Okay. So I'm guessing Groth and Plonk are already live on testnet?
Yeah, no, we are in testnet, and mainnet is going to hit really, really soon.
Got it. Okay, thank you.
Are there any more questions for this guy? If not, I have one. Don't go. Because you mentioned that there's a lot of cost optimization, but share us some numbers, like we want to see it, like how cost effective is it?
Well, in testnet we tried, and you could get it for more or less 10% of the original cost, but then in mainnet there will be some other things.
10% it is, to read. Okay, thank you, man, and stay with us. And right now, let me introduce on stage Mehdi, the CEO of Reclaim Protocol.
Okay, so thank you for having me. I am Mehdi from Reclaim Protocol. I'm going to talk about how AVS really saved our ass. So, of course, zk-TLS, all of you might be knowing, is also closely associated with all of these cool technologies, you know, ZK, TE, MPC, FHE. But the truth is, nobody cares. But there's also a lot of privacy-preserving attributes for zk-TLS. But hey, again, nobody cares. And hey, it is decentralized. As you might have already guessed, nobody cares either. So all of these things are super important technologies, but when the rubber hits the road, a lot of people don't really seem to care. These are not the selling points. These are nice to have, but these are not the selling points. So I want to talk to you about a case study. This is a case study of a credit card company that wanted to do address verification. And the way that they are doing address verification is through a proof of, hey, where were you picked up by Uber? Where did you order food using a food delivery service, and so on. So using those address points, they were able to do an address proof verification. Wow, the time is really running here, so I'm going to run. All that they care about is the data that they need, right? So the data is all they care about. The privacy and the security were lesser of a concern. And they could have done it on-premise, they could have done it on the cloud, but of course they want a cloud solution. And the endpoint that they are using is going to be us. So we are going to be an endpoint provider, and everything else is a black box for them. They really don't care what happens inside the black box. How do you get the data of where Uber picked me up is not something that they care about. So, okay.
Unfortunately, the time is out. Do you guys have some questions for these guys, or should we let him continue? Okay, maybe just use this 1 minute.
Yeah, I'll use this 1 minute because I didn't even get to anything interesting. So yeah, you could generate the proof from the customer's device itself, but then, hey, all of the data that is going to go through the endpoint is going to be visible to the endpoint itself. That's going to be us. And we don't want to get into that compliance. We become a honeypot for all of the data. And because of that, we want to do some kind of a multi-party computation in which data is encrypted without it being visible even to us. So that is something that we use AVSs for. And thanks to AVS, it was really easy for us to spin up the nodes that would do the multi-party computation and still keep the data secure and encrypted so that we don't have to do any compliance per se. So yeah, that's pretty much it.
Okay, thank you. It was 3 minutes, like we're still counting. Yeah. And right now, let's have on stage Michael, the co-founder of Brevis Network. Michael, the stage is yours.
Hello, I'm Jay from Silence. Our mission is simple, to build compute engine for open data economy. And we are building democratization of privacy preserving computation. So you might have heard data is the new oil. But we believe it's a bit of an understatement. Why? Oil depletes. Once used, it's done. But if you read this abstract, probably it's the most beautiful abstract I have read in my entire academic career. Probably you can just read it and my talk is done. This is what we are doing. Data has a very beautiful property of non-rivalry. If you fuse multiple data sources, you can actually reach social optimal economics. And that will help to boost general global economies. And that's what we are building actually here. First thing is we are building a distributed compute engine using multi-party computation. And therein we are inviting, bring your own data. It can be enterprise data, your data. It can be from your collaborators. And then there's a compiler in between. You can write any arbitrary logic over here. And this compiler converts that into a set of opcodes, and that executes. There is a catch here. Data never, ever leaves the source. It just connects with this distributed compute engine. And then you can run all your compute arbitrarily. And we are building two key components here. A marketplace where you can deploy any logic you want. Our machine will understand, run the logic, give you insights. It will create a huge motion around economics from both data in and both inference out. And that's what we are trying to enable using AVS. This private compute engine will run on EigenLayer. Actually, you can go on Twitter of ours on Silence Lab. We just released a white paper today, and that will tell you about how we are adding this to multiple use cases, particularly in open finance. Already, we are live with multiple use cases like cross-border compliance, personal data vault, open finance, DPIs, and open health stack. And our mission is to enable optimal social and economic value for data economy. Thank you.
OK, thank you, Jay. Are there any questions for Jay from the crowd? If not, let me just say sorry, Jay, for introducing Michael instead of you. But we still have 1 minute on stage, so don't leave. We have some questions. You could share some photos on the whiteboard. You said you just released it. Am I correct?
Yeah, the white paper.
What was the release date and what's inside? What?
Right, so the white paper talks about open finance and the role of privacy. Currently in open finance, there are data providers and data fiduciaries. But data providers don't have incentives to push data. But if we use what we are talking today, we can clearly encourage these providers to participate because data consumers never ever sees data. They just can compute. And that's what the core proposition is about. Yeah, thank you.
OK, perfect. Thank you, Jay, for coming. And stay with us because there's knockout round after it. And right now, let's welcome on stage Michael, co-founder of Brevis Network.
All right, hi everyone. I'm Michael from Brevis. So what Brevis is it's a ZK off-chain verifiable computing platform that allows you to offload heavy and data-driven computation from blockchain to an off-chain environment. In this off-chain environment, you're not only just doing the computation itself, but also generate the ZK proof of the computation at the same time. After that, what you can do is you can submit the ZK proof and the computation result back to the blockchain so that the blockchain can verify the proof very easily with extremely low gas and consume the computation result directly as if the entire computation happened on chain. So the purpose for Brevis is to treat blockchain really as the glue point of your decentralized application and offload very complex and heavy computation in an off-chain verifiable computation environment. So, there are so many different use cases for Brevis. There are mainly 3 categories. Things like intelligent DeFi, where you can dynamically change your DeFi protocol parameters based on historical user behavior and also market condition, because you can prove, for example, what is the trading volume of this particular user and give this user a fee discount. There are also consumer adoption use cases. For example, we partner with Euro, who will be launching a continuous protocol incentivization protocol to allow users to directly mint token out by proving on-chain their historical interaction and contribution to certain protocols like Euro stable token ecosystem. And there are so many other exciting application use cases as well in the infrastructure space, but that's my time slot. Thank you.
Actually, it's not. We still have 5 seconds and then one more minute of a Q&A. Do you guys have some questions for Brevis?
All right. Any questions?
If you're not, I have one because you already mentioned some use cases and there's like consumer adoption.
Yep.
Let's explore that more. Like, tell us about the use cases or maybe potential case studies you are about to drop.
For sure. I think one use case I really want to highlight here is the token distribution use case, right? So for any blockchain project, one of the most important things is how do you do token distribution. But today, it's all based on one-off airdrop, but one-off airdrop hurt both users and also project. And what we're trying to change here is to use a decentralized and trust-free way to continuously distribute and minting tokens for the users by allowing them to generate a trust-free ZK proof of their historical interaction with the protocol ecosystem.
Thank you so much. Thank you so much. So right now we have a little bit rescheduled agenda. Let's welcome Nuffle Labs, but instead of Alton Turner, the founder, we have Yash on stage. So the stage is yours. You have 2 minutes and 1 minute Q&A.
All right. Hey guys, I'm Yash, Chief of Staff at Nuffle Labs, filling in for Alton. So we are building Nuff Protocol. We've partnered with EigenLayer to extend the protocol beyond the Ethereum L1. And the idea is that restakers will be able to stake any token from any chain, and AVSs will be able to secure their service with a diverse basket of assets. So the benefits for restakers is that you'll be able to stake any token from any chain, and the assets will stay on the native chain. So we are getting rid of bridging risks. We'll also introduce something called curated restaking. So you'll be able to stake to curated basket of AVSs based on your risk-reward profile or AVSs that you're aligned with, or just AVSs that you would like to support. On the AVS side, you're able to benefit from having a diverse basket of assets to secure your service. Currently, mostly people are using just ETH to secure their services, and we'll introduce cheaper assets or assets that they're more aligned with. And then for LRTs, we will allow them to deploy on any chain and create these curated bundles, sort of like indexes for restakers to stake to. That's Nuff Protocol.
Okay, but we still have some time. So what happened to your presentation, man? Like, is it not working?
Yeah, it's not working. Okay, we got it. The way the protocol works is that you stake from your native chain, let's say Arbitrum. You stake ARB, It gets locked on Arbitrum, and then we use our NFFL AVS to do message passing to Ethereum L1. So this is where we're getting rid of bridging risk.
Okay, no worries. I'm a professional MC. I give you some more time to finish up the presentation and show us some slides as well.
Yeah, cool. And yeah, so messages get passed to EigenLayer on ETH-L1, and EigenLayer is where the accounting is managed. So slashing and rewarding will be maintained by EigenLayer on ETH-L1. And yeah, just to what is going on?
Oh man, it's all yours. Like you have to manage and deliver on time.
Benefits for restakers is you can stake any token from any chain. Like I said, you can stack yield from L1s, LRTs, AVSs, and Nuff. And then you can stake to a curated bundle or an index of AVSs, and we're getting rid of bridging risks.
Okay, now it's time, but stay with us for the knockout round. And right now, let me introduce on stage Kevin Lapsor, the founder of EthGas. Kevin, the stage is yours. You have 2 minutes for the presentation, and there's 1 minute Q&A in the end.
All right, good evening. My name is Kevin Lapso, founder of EthGas. Where we are. And I hope you guys are doing well in Bangkok. EthGas is a block space marketplace. We work in between validators and gas buyers, be it like traders, searchers, block builders, and that type. There's about 14,000 validators. Whole bunch of really big ones that we've probably heard about, but almost 14,000 very, very small ones. Now, yields to all the validators have been dropping over time, and they're about 3.5% for anyone that's like an ETH staker. Now, one of the issues that I have is that basically the entire block building process is very inefficient from a value capture standpoint. And so that's where these yields come from. They come from an auction process in between the users and the validators. Now, what we're doing is we're completely changing that process through which the gas buyers or traders interact with validators. What we're doing is we're enabling the validators to sell their block space, to sell parts of their blocks in advance. These are called pre-confirmations. It's a type of commitment or it's a type of guarantee. But the difficulty is that when providing a guarantee, you need to provide collateral. Providing collateral invariably favors the larger validators. And so what AVS does is it enables the smaller validators, those 14,000 validators, to also participate in this and provide collateral. And so through these nascent, through these forthcoming block space markets, we can boost yields across not only the big validators, but all the way down to the very, very small validators themselves. And that's it. Thank you.
Guys, we still have like 7 seconds left and 1 minute for the Q&A. Do you have any questions for Kevin? Are there any questions for Kevin? So Kevin, if there's not, let me ask you, like, how expensive is the gas right now?
Oh, I haven't checked recently, but it's spiked as high as like 40 in the base fee, and it's come down a little bit since then. But it moves a lot, and that's the whole point. How do we hedge it? How do we kind of protect ourselves against this volatility?
So who would be to hedging the prices? Like, who you think like is a perfect client for you? Maybe this client doesn't exist yet, but who would be the ideal partner?
It's who buys gas. Who wants stable gas prices? Who wants them to never kind of rise and fall? It's kind of everyone. If you think about it, everyone's looking for certainty. And when you have certainty, that's just easier for everyone. So institutional traders, searchers, down to the retail person.
And what's the stage of the institutional trading right now? And like, share us some insights.
We're on testnet and ready to go to mainnet sometime in Q1.
Okay, perfect. There was some alpha there.
Thank you.
Okay. Thank you, Kevin. And right now, stay with us for the knockout round after that. And right now, on stage, Murat Akendis, Chief. Okay, so it's not Chief MEV Punk. So you can introduce yourself, but it's, what's the name? It's Primev? Oh, it's Francesco. Sorry, man. So the final, it's Francesco Mostres, the CEO of Bolt, now on stage as the last player.
Hello, everyone. So I'm going to go pretty quick and present what are we working on. And it's Bold, which is a solution to enable pre-confirmations on Ethereum. But what are pre-confirmation in this general term? It's the ability to interact directly with proposers, validators, node operators, enabling credible commitments, and backed by state capital. This is a very strong primitive because it allows a fully trustless way to interact with the proposer and enable many new primitives that we're going to explore. The first primitive that we wanna explore is inclusion pre-confirmation, which are instant guaranteed inclusion type of solutions. It's a new type of transaction on Ethereum. But what it really is, it's something that's instant. It means that users are capable of sending a message or transaction directly to the validator and receive a promise of inclusion in like 200 milliseconds. But what does this really enable? Enables transfer approvals. Almost 70% of Ethereum transactions could actually be pre-confirmed, meaning they get this loop of confirmation in like 250 milliseconds. And just by talking to the validator and asking, can you include this? Yes, perfect. So it's done. This is a new primitive, and we think new apps are going to use it, and is also guaranteed, meaning that proposers have the ability to give you a guaranteed inclusion, meaning now users are capable of receiving a message in return for something that's guaranteed by economic collateral, rather than just waiting for that. I don't have time, but what's good about being guaranteed is that you can enable inclusion.
Time out, but if we don't have questions from the crowd, we can let you finish. But there is one. There is one question from the crowd. Can we have Mike?
Where in the actual transaction lifecycle does the pre-confirmation happen? When the user signs the transaction, are they interacting with an intermediary smart contract? This is just a general question a question I don't know the answer to.
Yeah. So the user sends a transaction to dedicated RPCs that are just sort of watchtowers that direct the transaction to the next opted-in proposer, and he returns a confirmation to them. So it's just a matter of switching your RPC in a wallet or in a dApp or whatever. And it's a pretty powerful primitive because we could enable a lot of non-state contention transactions to have just 200 milliseconds of round-trip time to get inclusion. And what's the good thing is that it will seem to transact on a website, on Web 2, when in reality you're transacting with Ethereum. So, yeah.
Okay, guys. That was the last keynote for now, but let's have on stage everyone from the AVSs that we're presenting right now. It's a knockout round. We will have 2 questions for each AVS, and it's you, guys from the crowd, are gonna vote which answer was the best one. So let's have all the speakers, all the presenters from the previous session on the stage right now, and we ask 2 questions each, and you guys gonna vote. Either you could just applaud or you can scan a QR code and vote live. Guys, do you feel ready? Are your mics working right now? Can you do a check, mic check for us?
Mic check.
Okay, everything seems to be working right now. Is everybody on stage? Because I kind of feel like we're missing someone still. Ali, are you coming? I think you are. Yeah, 1 more minute, and we have the full crowd here. Here we are, okay. So, it's a recap. So we ask question each. You have like really not much time to answer it. It's just 30 seconds to respond. So, first question is, and we're gonna start with you, is what type of AVSs have the highest natural synergy with risk-taking or beneficial, sticky the most? And why?
Well, to me, verification layer and coprocessors, basically verification layer allows to reduce the costs, and so we can move execution off chain, okay? And if the costs are too low, then we can do very cool stuff with all that. I am Diego.
That was pretty fast. We have 30 seconds. You don't have to speed that much, but yeah, take your time. 30 seconds, go.
Oh yeah, so I think EigenLayer fundamentally is a way to launch a proof of stake system in a very cheap and scalable fashion, right? So like from that first principle point of view, I think the most beneficial and sticky ones are the ones that is targeting users, mass adoptions, and these kind of use cases will actually stick the most. The ones that are purely focused on like chains, infrastructures, and very complex stuff. Yes.
You have to find the sweet spot between this guy and you. Okay, so 30 seconds, go on.
I think risk-taking is a very powerful primitive, and if you can use it to enable something new to be done on Ethereum, it's probably the best. So in the case of having something like a new type of transaction type as inclusion reconfirmation, yeah, it's probably the best use of this economic collateral that's out there. Yeah.
Okay, Kevin, do you have the mic ready? Okay, answer the same question in 30 seconds. The time is running.
Kevin from EthGas here. Kind of echoing some of Fra's comments here. I think as it's related to collateral management or counterparty risk, I feel like if AVS can open up the counterparty risk or the credit markets entirely, that opens up a vastly new asset class for crypto as a whole.
Okay, great. That was pretty quick one. And Lee, now it's your time and your 30 seconds to use.
Any AVSs whose data to be validated can be made small enough will benefit from using EigenLayer as a risk-taking protocol. And in our case, it made much more sense to reduce the data size, which is a ZK proof size, than to reduce the computational complexity. So this is exactly what we're using EigenLayer for. Thank you.
Okay, that was pretty quick. So right now, another 30-second answer.
Right, so any protocol or product which has two risks. One is if I am doubting that if they are computing a job properly or not, number one. And number two, if I have doubt that multiple parties in that protocol conclude, those two risks can be pretty much averse by the AVSs. And that's where I feel it's the best fit. So collusion and guarantee of execution of a job.
Okay, we're making it on time. Now 30 seconds, the time is running.
Yeah, I'm not, testing, there we go. Yeah, I'm not gonna pretend I'm a developer. So from our AVS engineer, AVS that have an objective provability for slashing and have no hierarchy for protocol participants.
That was quick, like a mic drop. Okay, and you, as the last one. Oh, not like that. Last man, and we have Ali. Okay, the time is running, start.
Yeah, so AVSs that are intersubjective require social consensus, like bridges, fast finality, or oracles are the best use cases for AVSs. And they're also most likely to generate the most revenue. So yeah, that's it.
Ali, you can answer it in 30 seconds, and you're going to answer the second question as a first guy.
Okay, so I think the highest synergy that you can have is an AVS that reuses the fact that you're an L1 validator. So for example, an AVS that does shared sequencing between L2s and the L1, because you already know that what the validator is an L1 validator and has access to the L1 state or can propose. So that's the type of the highest synergy, I think, is a shared sequencer between L2s and L1.
Okay, perfect. That was the question one. We have second question, and let's do from your side. So how to evaluate the amount of risk-take security required for the robust operation of AVS?
Yeah, I think the best way to evaluate it is essentially how much value could potentially go through your network, not at a single time, but like in the worst case or best case scenario, how much value do you have? And then your network, your AVS should be secured by something more than that. But then you also have to take into account if some of that is secure, if some of that collateral is securing other AVSs. So in my opinion, you really want collateral that's only securing your AVS.
Perfect. Let me just remind you guys that you are probably have possibility to vote right now live. So let's pick up the winner and let's have 30-second answer from you.
All right, for this one I'm reading, define a time as to how much operation you are doing, calculate the value, say, of your bridged asset, and provide more crypto economic security than that value.
That was quick. Maybe that's a hack. If you're reading it, it's going to be quicker. So 30-second answer right now.
I'm going to try to not read for this one. We'll see how it goes.
It's basically what he said, but magnitudes more is the word that my developer used, like shitloads more.
Oh, that was very quick. Maybe the crowd appreciates that. Jay, you have still 30 seconds to answer.
Right. So I see the restaking security as an insured cloud. So if I can get a guarantee that all operators are bombed today, but still I can return back money to my customers, then that's the value I'm looking for.
Perfect. We're going to wrap up it pretty fast. 30 seconds. The time is yours.
Yeah, I believe the operators will eventually find the right amount versus the reward. So we just leave it to the operators. But what's more important is to enforce the minimum staking amount, which must always exceed the cost of breaking the system. So I think it's more of a challenge to enforce that adaptively against the roll-up liquidity. Thank you.
Okay, perfect. Kevin, are you going to use the entire 30 seconds, or are you going to be faster?
We'll see. Kevin from EthGas here. This is really a question of like credit risk, and so it's a function of what's the probability of loss and the magnitude of loss. In the event that you're able to actually simulate or analytically compute the probability of loss, then you can actually use that to generate the amount of collateral required for that. If you're unable to do that, that's when third-party research agencies, i.e. like, can give a qualitative estimate around credit risk. So ultimately, it's a credit risk question, a probability of default, and a magnitude of default together.
Perfect. Just on time. Just on time. Francesco, the time is yours.
So the amount should be greater than the maximum pain that you can provide to the user. Economic pain, meaning like, in the case, in my mind, it's the case of inclusion reconfirmation, you would look at what's the worst case scenario for the user, and the amount of state collateral by the validator should be higher. So it's really like that, and that's it.
Perfect. Almost on time answer. And right now, Michael?
So the security, the amount. Okay, I guess I was right. Oh yeah.
No, the time is running.
Yeah. So the amount of stake should be, in theory, should be equal to the amount of like possible losses in the system. Like the slashable restake security should be kind of equal to the amount of possible loss in the system, in theory. But in practice, I think it's going to be really kind of a market-driven approach here, because like EigenLayer provide this kind of economical scale for restake security with multiple different AVSs sharing the same amount of security at the same time. So it's really going to be market-driven.
Perfect. And last one, Diego?
Well, everybody gave really complete answers, so what I am going to say is translated into a simpler language. So ensure that the person that misbehaves suffers such damage that he'd rather be fighting the guy over there on top of the ring. Thank you.
Okay, maybe we're going to see some fight tonight. Like, who knows? So guys, I hope you took your chance to vote, and right now, let's see who answered the best. And apparently we have like a winner. You guys don't know it, or you know it already? It's Radius, actually. So, oh, no, we're still counting. So, okay, guys, take your chance. You already see live who answered the best in your opinion, but maybe it's not gonna be just. Let's still fight. We have some runners-up. AltLayer has some chance. Espresso as well. But Radius is a leader for now. Is it gonna change? No or yes for Lee. D.H. Lee Radius. You won this round, and the gloves are yours. So guys, let's wrap it up. I just want to say thank you to all of you guys on stage and all of you guys in the crowd. It was amazing knockout round. Sorry for not being like really professional MC, but I did my best, and I hope you're going to have some fun tonight. See you around, and thank you.